Hey, Mr. Height, we're going to go over the Chapter 1 practice test. I just created this version of the test today that actually took the actual test, one of the more recent versions that I've made, and then I did all of the problems to be around the same level of difficulty or perhaps slightly more difficult than you're going to see on the actual test. So it's the first time I've worked through this, so I might be making some changes as I go. So be patient with me, but I figured I might as well record it while I'm working through for those that might have questions in case you're not able to get those questions answered in class. So here we go. A bunch of true or false questions. We want to move through these relatively quickly. A lot of them you'll be able to do kind of by sight or some simple calculator stuff. So the first one's asking about a horizontal asymptote. So I'm going to go ahead and get in my calculator here. Let me bump down my brightness. You can actually see it. And I'm going to put in this function. So we've got 4x over 2x minus 1. Those parentheses are important. We'll go ahead and graph it with the standard zoom window. And it says that the asymptote is y equals 2. It looks like it is. I'm going to go ahead and graph another line at y equals 2. That line's pretty well. I'll look at my table as I scroll far down or up my table so that I'm looking at really big x or y values. We should be getting closer and closer to 2, and I see my y values doing that. So I'm going true for this first one. Second one, the domain of this function, or this function has a domain from -3 to 3. I could try graphing this really quickly. That's probably the quickest way to go about it, and see if my graph is showing -3 to 3. 9 minus x squared. Okay, I am just seeing from 3 to 3, so I'm thinking it's definitely from 3 to 3. The question is, would they be brackets? Could I put -3 in here and make this still work? If I plug -3 in for x, I'd have 9 minus 9, which would be 0. I'm allowed to take the square root of 0, so 3 works. -3 works, and 3 would work also. This is going to be true. If I had to actually work this out, since this may come up later on, we've got a square root. The restriction on the inside of a square root is that it must be greater than or equal to 0. I would solve that, and I'd have to solve it graphically. I know that this is going to be a parabola opening downwards. It's going to have a y-intercept at 9. If I'm not sure what it looks like, I could graph 9 minus x squared. Pretty sure it has x-intercepts at 3 and -3. Yeah, totally. So 3 and -3. This says greater than or equal to 0. That would be the region in between -3 and 3, and it would include them also because of the or equal to. So that's true also. This function is an odd function. Let's go ahead and just do the work for this. F of -x would equal 3 times -x to the 4th minus 2 over 4 times -x to the 3rd minus 5 times -x. So what's going to happen here in the numerator, x negative to the 4th is going to disappear. So that didn't change in the numerator from my original. The denominator, yeah, so that negative is going to actually stay because when I cube it, I'll still have a negative. This would be -4 x to the 3rd. This is going to turn into a plus 5x. I could factor a negative out of the denominator there. Would be essentially factoring a -1 out of the whole thing. And the new denominator would become 4x to the 3rd minus 5x. That matches perfectly. So this is the negative version of f of x. So yes, it is odd. That's true. All right, this one is bounded. If I know that this is a logistic function, I'm going to know that it's true because we learned that the logistic function does have 2 horizontal asymptotes, which means it's bounded above and bounded below. If I didn't know that, it might take me a little bit longer. I need to type it into my calculator. But let me just confirm here. -2x. And I see my horizontal asymptote. I see another horizontal asymptote there at 10. So yeah, that's true. It's bounded above, bounded below, which means it's bounded. E to the negative 3x has no local maxima. If I know that this is an exponential function, I know that this goes from 0 up to infinity. So I know that this would be true also because it doesn't top out anywhere. If I didn't know that, it'd be a simple matter of just plugging it into the calculator. And looking at the graph, negative 3x. Oh, I need parentheses, negative 3x. And yeah, I can see it shooting up to positive infinity there. So it's never going to top out anywhere. So it does not have a local max. That's true. Got a feeling that these are all going to be true. That's fine. Ln of x minus 3 is increasing over its entire domain. I know that that's going to be true because I know what the natural log graph looks like. But if you don't remember that from last year or from our work with the parent functions, then go ahead and graph it. And you can see that it is increasing, and it's increasing over its entire domain. If f of x and g of x are both odd functions, then h of x, which equals the product of f of x and g of x, is an even function. So here's what I have to do for that. So h of x is equal to f times g of x. That means it's equal to f of x times g of x. That's what that notation means. If they're both odd, then f of x is equal to negative 1 times f. Okay, hang on a second. Let me back this up. Let's do h of negative x. H of negative x. Because I want to see if h of x is even or odd. So I need to start with h of negative x. So I'm plugging in f of negative x and g of negative x. This says it's a product. All right, so if they are odd, then f of negative x is equal to negative 1 times f of x. That's the definition of it being odd. And if g of x is odd, then g of negative x is equal to negative 1 times g of x. Which means, well, those negative ones are going to cancel out, then that's just f of x times g of x, which is the same as h of x. Which means, yeah, it's even, so that's true. All right, finding the domain algebraically. Zoom in so I can get a better look at this. All right, we got a fraction here. Could potentially cause some problems in the denominator. The numerator doesn't have anything I got to worry about in it. No square roots or anything like that. So we'll look at the denominator here and write our restriction. 2x squared minus 5x minus 12 is not equal to 0. So we need to solve that. I'm going to solve that by factoring. I suppose you could use the quadratic formula, but that would take way too long. So that's 2x and x. Factors of 12, I'm going to guess 3 and 4. It's going to be 8, 3. So I think if I did 3 and 4, 2 times 4 is 8 and 3. So if I add a negative 8 and a positive 3, 3x and negative 8x would give us my 5x. That's it right there. So then I would break these up. 2x plus 3 is not equal to 0, and x minus 4 is not equal to 0. Do a couple steps of algebra to solve those. 2x not equal to negative 3, x not equal to negative 3 halves, and here x not equal to 4. So x is going to be everything except for at negative 3 halves and at 4. So we have 3 intervals we need to write down. It did say interval notation. So first one's from negative infinity to negative 3 halves, then from negative 3 halves to 4, then from 4 to infinity. All right. Second one, we got all kinds of stuff going on in this. All right, well, there is a denominator. So we're going to have x minus 2 times the square root of 6 minus x not equal to 0. I also have a square root in the numerator with an x plus 5 in it. X plus 5 must be greater than or equal to 0. That's the restriction for a square root. And I also have 6 minus x, also greater than or equal to 0. So we'll solve all these. Give me just a second. All right, we're back. That's what happens when you record after school. Lots of interruptions, maybe more to come. All right, let's do this. Solving this, we'll split it up. Since it's multiplied not equal to 0, we can do x minus 2 not equal to 0. 6 minus x and a square root not equal to 0. This one's easy to solve. This one here, yeah, let's square both sides and then add x to both sides. So x can't be 2 or 6 so far. Solving this, what are we going to have? X is greater than or equal to -5. And over here, negative x greater than or equal to -6. Multiply both sides by a negative, that's going to flip my inequality. So x is less than or equal to 6. So I have 3 things to stack up here, and I'm looking for where they overlap. So I got to be careful and get these right. Important numbers are -5 and 2 and 6. Okay, so let's start with these guys. It can't be 2 or 6, so I'll leave those as open dots. But everything else for these ones works. And then we've got greater than or equal to -5. So it can be equal to -5 or greater than -5. And then for this, less than or equal to 6. So it could be equal to 6. Could be less than 6. So I'm looking for where all 3 overlap. So they do overlap at -5. They overlap between -5 and 2. They do not overlap at 2 because of the open circle there. All 3 overlap between 2 and 6. They almost all overlap at 6, but we have an open circle, so we're here. So final domain, we only have 2 intervals, -5 inclusive to 2, excluding 2, picks up on the other side of 2 and goes up to 6, not including 6. All right. Number 3, find the equations of horizontal and vertical asymptotes, if any. No work is required is a good indication that probably you're going to be looking at your graph on these. So let's graph this first one. So parentheses around the numerator and denominator, just to be safe. And we'll go over standard zoom window. All right, I see a vertical asymptote there. Looks like at -6 and +6. I'm going to confirm with my table. I'm looking for errors at -6 and +6. Here's one at 6 and at -6. Good. And then if I keep scrolling, it should show me my horizontal asymptote as I go really far to the left and right, which means really small values of x or really big values of x. X tends towards a horizontal asymptote. It looks like it's getting closer and closer to 0. If I go really far in the positive direction, I'm going to guess that we're going to get closer and closer to 0 also. Yeah, definitely. So for horizontal asymptotes, y equals 0. Vertical asymptote, x equals -6, x equals 6. Equations are important there. Make sure you're giving equations. Just looking at the graph again, yeah, definitely looks like a horizontal asymptote at 0, verticals there and there. Okay. Next one. So parentheses around numerator and denominator. All right, we got one. Well, that one's hard to tell. We'll look at the table and hope the table shows us. I think the horizontal looks like it's pretty close to 3. Or is it 4? Boy, that's tough to tell too. Let's try 3. That's kind of low. How about 4? Oh, what happened? Gonna have to graph the whole thing again, I guess. That's a little tricky too. I type everything in right. Yeah, all right, well, let's look at our table. All right, we got an error at 2. That means there's a vertical asymptote at x equals 2. Got another one at -4, so x equals -4. There's another vertical asymptote there. And looking at the graph, that seems about right. 2, there's a vertical asymptote, -4 would be there. That seems to be splitting those pretty good. All right, looking at the y values, so I want to go really high in the x value and see what we're tending towards. This is interesting because that's coming up. Is it gonna head towards 4? Tell you what, I'm gonna go to my table settings and have my table start at like 100. So yeah, I can see that getting closer and closer to 4. I bet if so what are we at, like 3.92? I bet if I have my table start at 1,000, we're gonna be even closer. Oh yeah, okay. So it is getting closer and closer to 4. So y equals 4 is going to be my horizontal asymptote. If I wanted to double check, I could always check like -1,000, see what my y values are. Yeah, that's super close to 4. And I can see it actually getting closer to 4 right there. So cool. Feeling confident about those. Let's move on to page 2. All right, we got a set of parametric equations here. They want us to find ordered pair if t equals -4 and t equals 42. All right, so basically we just need to plug -4 in for x and for y. So for x, be -4 plus 3, that's -1. And for y, -4 squared plus 5 times -4. So that's 16 minus 20 should be -4. Just gonna double check in my calculator though. It's been a long day. Yeah, feeling good about that. Let's go ahead and do for t equals 42. So my x would be 42 plus 3, that's 45. My y is 42 squared plus 5 times 42. Definitely using the calculator this time. $19.74. Okay. Eliminate the parameters. So I need to write an equation that just has x's and y's in it. So x looks easier to solve for sure than y. So x equals t plus 3. So I'll get the t by itself in this equation. So I would get x plus 3 equals t. My y equation was y equals t squared plus 5t. So let's leave some space for some substitution. I pulled both of those t's out, and in their place, we're going to put x plus 3. So y equals x plus 3 squared plus 5 times x plus 3. It does say to simplify and give an answer with no parentheses. So this is where having that shortcut for squaring a binomial comes in handy. 3 times x is 3x doubled would be 6x. And here I'm just distributing. So what do we have? X squared, 6x and 5x is 11x, 9 and 15 is 24, so plus 24. All right. We got ourselves a couple of equations. We're going to do some of these fun things. Awesome. So f minus g of 10. So I just need to do f of 10, which would be the square root of, yeah, see, I need to make a change here. Let's do 20 here instead. All right, square root of, gosh. Let's do 4. F minus G of 4. That's probably what it looks like on yours, because as soon as I get done recording this, I'm going to go change that. So what do we got? So x plus 5. So we got 4 plus 5. Yeah, that's going to work out better. And then minus, and then G of 4 would be 4 squared minus 9. That parentheses is important there. So we need to subtract the whole thing. So I got the square root of 9 here, which is 3. Minus here, I got 16 minus 9. 16 minus 9 is 7. And 3 minus 7 is negative 4 for our final answer. F over G, G over F of 4. Okay, so G of 4 is going to be 4 squared minus 9, and then we're going to divide that by F of 4, which would be the square root of, we're plugging in what, 4? 4 plus 5, so what do we got up top? That's 16 minus 9 on the top, square root of 9, which is 3 on the bottom, so 7 over 3. All right, they want us to do G of F of X. So that's G of F of X, which is G of, what is F? Square root of X plus 5. And then my G function is X squared minus 9. Plug square root of X plus 5 in there. The square root and the square are going to cancel, so we'll get X plus 5 minus 9, which is X minus 4. And then I noticed that this down here has to do with that. So I'm going to go ahead and find this now. Remember that thing that we have to do. We need to make sure that the domain of this thing, which I would think the domain of this is all real numbers, but we have to also include any restrictions on the domain of F. So I have to look at my F function, and I don't have it on the screen, but F of X was the square root of X plus 5. So I need to worry about the domain of this. Is there anything that's not in the domain of this? Yes. X plus 5 is inside of a radical, so it must be greater than or equal to 0. So X must be greater than or equal to 5. So anything where that's not true is going to break the F function, which is eventually going into the G function. So this has to be included in the domain. So it's not all real numbers, because that doesn't have any restrictions. It is anything greater than or equal to 5. So the domain of G of F of X would be from 5 to infinity. All right, let's go the other way and do F of G of X. So F of G of X, G was X squared minus 9. We'll go ahead and plug that into our F function, which was square root of X plus 5. And in place of X, we're putting X squared minus 9. We'll simplify. X squared minus 4. That does not simplify any further. So that's it. Okay. So we're going to find the domain of F of G of X. Now, G of X did not have any restrictions, because G of X was just a polynomial, X squared minus 9. So we don't have to worry about it like we did for this one over here. But we do need to find the domain of this guy. So it's underneath a square root. That means X squared minus 4 must be greater than or equal to 0. And we need to solve that. We can't solve it algebraically right now, but we can solve it graphically. I know it's going to be a parabola opening up with a y-intercept at -4. Question is, where are my x-intercepts? I think they're at 2 and -2. I could graph it and confirm that really quickly. X squared minus 4. So I'm just graphing the x squared minus 4 part. Yes, I do see x-intercepts at 2 and -2. And we're looking for where it's greater than or equal to 0. That's over here and here. So we could, when we solve that, the solution would be from -infinity, should have a parenthesis, up to -2, bracket, and then picks up again at +2 and goes up to infinity. That would be the domain. Right along. List transformations in order that would transform the absolute value into the given function. So we just have to go through and list our transformations. It says no work required, but I'm going to go ahead and work this out from y equals the absolute value of x. So that's where I'm starting from. So what do I want to do first? I'll go ahead and take care of that 3 on the outside. So that would be a vertical stretch by factor of 3. You must say vertical there. Don't just say stretch. You're going to lose half your points for that step. That -4, that would be a shift down by 4. All right, the question is what to do next here. If I pull out the x and I replace it with x plus 2, then I would just be able to pull out the x and replace it with the 0.5x. So I think I want to do the +2 first so that I don't have to change that later. Let's see how it works. I may have to backtrack here. So I pulled out the x, replaced it with x plus 2. So that's going to cause a horizontal shift. +2 would move us to the left by 2. And then I'm just going to pull out the x and replace it with a 0.5x. The +2 would remain then. Yeah, and that's what I want. Okay, the question is what's happening here. 0.5x is the same as 1/2 x. So a 1/2 x, that's going to be a stretch, horizontal stretch by a factor of 2. There's a way that I could have gotten away doing the stretch here first and then the shift, but I would have had to shift by a different amount because it would have ended up in parentheses. So that works out. Okay, let's do this one. So I think I'm going to go ahead and start with the negative on the outside. So that's going to be a reflect over, it's on the outside, so vertical, it's going to reflect over the x-axis. Then the +2. So that's shifting up 2. All right, this time around, I think I want to do this, the 3 first, then I'll have 3x, and then I'll pull the x out and replace it with x minus 4. Yeah, that's, I think, let's double check. There's a reason I'm using pencil here, folks. So pull out the x, replace it with 3x. So multiplying by 3 is going to actually cause a horizontal shrink. By 1/3. And now pull out the x and replace it with x minus 4. And we're going to get that. Yes, and that's how we want to do it. So that's going to be a shift to the right by 4. That answer, there's that answer. Not very neat. Hopefully Mr. Height can read this. All right. All right, this is all about local maxes and mins and increasing and decreasing. So we're gonna need to just graph it. Start with this first one. So this is all calculator. Parentheses around numerator and denominator. Start with my standard zoom window. All right, looks like I got a local min here and a local max here. So second calc min, a little to the left, little to the right, get best guess. -1 comma -3, huh, okay. And my local max, that's definitely to the left. I don't know how far over I gotta go, so I'll go pretty far. That looks like 3 comma 1. This is pretty interesting. I did not expect those to come out so clean. They will probably not come out that clean on the test. So just so you know, all right. All right, increasing. So when I look at this graph, the only place that's increasing is between those. Keep in mind, we're using X coordinates here. So from -1 to 3. All right, it's decreasing from -infinity up to the X coordinate here, which was -1. And then it's increasing, or it's also decreasing from 3 up to infinity. So -infinity to -1, and then 3 to infinity. All right. I'm doing the same thing with the other one here. This is a polynomial function. Double check and make sure that I've typed that in correctly. Triple check. Graph. All right. Oh, looks like there's a max way up here and a min way down here. So, okay, we're gonna need to adjust our window a little bit. I'm gonna go to my table and look. So my max, I'm gonna guess my max is somewhere around, I don't know, 1 or 2 here, and my min is somewhere around, I don't know. Go to table setting. It's still at -1,000. Let's have it start at 0. All right, so my max is somewhere around 1 or 2, and I'm seeing values 84. So I'm gonna make sure my graph goes up to a little higher than that, maybe 100. And then my min is around 7 or 6 or 7, it looks like. Got zeros at 5 and 8. So -16, -18, maybe I'll make it go down to -20. So I'm going to my window, gonna make my window go down to -20 and up to, we said like 100 or so. Let's see if that shows it. There we go. Ooh, yeah, we can just see that. All right, that'll work. Let's go max. A little to the left, a little to the right. Give us a good guess. What's it say at around 200? So we want 2 decimal place. So 0.70 comma 84.75. And for my min, little to the left, little to the right. We've got 6.63 comma -19.27. All right. So it's increasing at the beginning and at the end. So starts increasing at -infinity up to the X coordinate for this max, which was 0.07. It's also increasing from this minimum, which was at 6.63, and then all the way to the right to infinity. And then it's decreasing between the max and the min. So from 0.07, 0.70 rather, up to the X coordinate at the min was 6.63. All right. Even, odd, neither. All right. So we always start with g of -x. So 3 times -x squared minus 2 times -x plus 6. That negative is going to go away, so that's just 3x squared. What do we got? Plus 2x plus 6. So it's not even, because that does not match. This plus does not match. If I factor out a negative, we get negative 3x squared minus 2x minus 6, and this does not match either, so this is a neither. All right, starting with f of negative x. So we've got negative x squared minus 1 over negative x to the 5th plus negative x. All right, this negative is going away, so that's just x squared minus 1. That matches on the top. On the bottom, that's going to be negative. Positive times a negative is going to be a minus x. So it's not even because the denominator does not match. But if we factor a negative 1 out of the denominator, we would, remember when you're factoring out a negative from a fraction, you either factor out of the top or out of the bottom. You can't factor out of, you should not factor out of both. Otherwise, you're not factoring out a negative 1. You're factoring out negative 1 over negative 1. So I'm actually factoring out a 1 on the top and a negative 1 on the bottom, but that is a negative altogether. And that does match the original function. So that's equal to negative f of x, which means that we have a odd function. All right, x to the 4th plus 7. So h of negative x would be negative x to the 4th plus 7. 4th power, that negative is going to disappear. So we've got x to the 4th plus 7. That's the same as the original. So we're even. Last one, k of negative x equals 4. So negative x to the 3rd plus 1 over negative x. So that's going to turn negative. That's going to become minus 1 over x. I think we can factor a negative out of this, and we'll get what we want. Or x to the 3rd plus 1 over x. Yeah, that matches the original. So negative 1 times the original, which was k of x. So we're odd here again. Last page. All right. So let's zoom out so we can see the whole thing here. All right, we're going to find domain and range for each of these. So let's go ahead and find the domain of the original function. X minus 4 is not equal to 0 because that's in the denominator. So x is not equal to 4. So my domain is going to be negative infinity to 4. Yeah, I can't fit that all on there. That's all right. Negative infinity to 4, and then 4 to infinity. And if that's the domain of the original, then it must be the range of the inverse. So I'll go ahead and put that in there. Negative infinity to 4 and 4 to infinity. All right, let's go ahead and find the inverse, and then we'll be able to find the rest of that table. So to find my inverse, I replace all my y's with x's, all my x's with y's. Okay, I need to get y by itself here. So I'll start by clearing my fractions. So I got xy minus 4x equals 3y plus 1. Be careful, I'm not mixing my x's and y's up here. Next, I want to get all my terms with y's on one side. So I'm going to go minus 3y on both sides. And then I want to get rid of this 4x here because it does not have a y. So end result, xy minus 3y equals, and what do I got over here? 4x plus 1 or 1 plus 4x, same thing. Factor out a y. And then divide both sides by x minus 3. All right, there's my inverse. To find my domain, we're going to go x minus 3 not equal to 0, so x is not equal to 3. So my domain of my inverse is going to be everything except for 3. So negative infinity up to 3, gap, and then 3 to infinity. And that should be the range of the original function also. All right. This one's got a square root. We got to remember to do some stuff with square root, but I'm going to forget to do it and show you how to recover. So what I do need to remember to do is graph this. All right, square root of x minus 2. Let's do the domain of this. X minus 2 must be greater than or equal to 0. That's the restriction for square roots. So x must be greater than or equal to 2. So that's my domain from 2, including 2, and then getting bigger from that. So 2 to infinity. And that should be the range of the inverse also. All right. Let's try finding the inverse. So the y is going to become an x. The x becomes a y. Let's square both sides. Let's add 2 to both sides. Y equals x squared plus 2. So x squared plus 2. All right, so I think that the domain of this is my inverse. I think that the domain of this is going to be all real numbers. But that would be a problem because that would mean the range of the original was all real numbers. And I know that the range of this isn't all real numbers. That has a graph that looks something like that. The square root function shifted to the, actually it would be shifted to the right by 2. At any rate, though, it's only half of a parabola. It doesn't have the range that goes from negative infinity to positive infinity. So I have to remember when I do this, there's going to be something I need to cut off. So I'm going to go ahead and graph the original function and the inverse on the same window. So my original function is square root of x minus 2. And my inverse was x squared plus 2. And I'm going to graph these in my standard zoom windows. So go back to zoom 6, and that'll get me my standard because I was on a weird one before. So there's my graph of my square root, and here's my parabola. Now those are going to be inverses of each other if I chop off part of this parabola. I can't keep the whole thing. I need to chop off this piece over here and just keep the part that goes from 0 to infinity. So I need to add into my inverse here that I'm only keeping the part where x is greater than or equal to 0. All right, so I've chopped it off. I'm only keeping that part. That means that my domain is from 0 to infinity. And that means my range here is from 0 to infinity. And that actually matches the graph of the original function here, would just have a range that went from 0 up to infinity. All right, last one. Finding the equation for a function. So we're starting with x squared. We need to do 2 transformations. This first one's doing a vertical and a horizontal, so it does not matter what order we do them in. So it's going to be x squared. Here's my x squared. My horizontal is going to happen on the inside. I pull out the x and I replace it with, if I'm going to the left, it would be plus x plus 5. And then 7 unit this down, that happens on the outside. That would be a minus 7. All right, I also have, what do we got? A horizontal and then a reflection over the x-axis is actually going to be vertical. So again, I have horizontal and vertical. It doesn't matter what order I do these in also. So here's my x squared. Let's do the horizontal shrink with a factor of 3. So I pulled out my x. I'm going to replace it with, okay, reciprocal of that is 3. So 3 times x. And then a reflection over the x-axis, that's going to cause points to move vertically, so that'll happen on the outside. So a minus on the outside here. All right, and then you'll have one more, number 11, something novel, where you are asked to apply or connect concepts in a way that you may not have ever done, may never have done before, have never done before. I don't know, I'm not an English teacher. Just when you get to number 11, if you got time, just put something down, get something down on there that shows me you understand at least one of the concepts that's being discussed there. And I can get you some points. It's not worth a whole lot of points. All right, that's it. Well, thank you.